Hey folks, we're I think just starting to wrap up core, so hopefully uh, we'll get those folks in a minute or two here. So as we're waiting for them, every year I take the Etherpad and I try to archive it into the previous year and start over kind of with a new one. And it turns out that we have a now it's sort of a bug, but it's also a configuration setting where when I tried to copy and paste into the previous year's Etherpad, um, basically it silently fails. It looks like it did it, but then behind the scenes, the buffer was too big for what's allowed on the server, and it silently fails. And so, unfortunately, if you look at the Etherpad, there's these comments empty and empty. Um, we lost the 2021 record, unfortunately. I think that had happened previously, and I didn't know about this, so it looked like it was fine, but then it never correctly put anything into it. I did happen to notice this for the 2022 one though, and I have a local saved copy of that Etherpad. So I think I just saw that Adam Creatman adjusted it, so I'll try to get that in there so that we'll have the record from 2022. But I think unfortunately 2021 is gone. But the good news is that now we should have larger buffers, so hopefully this won't happen again. All right. So I guess they're still going in core stand up, but I can maybe get us started here while we wait. Um, there were two new pull requests this week that I saw, both from Igor. The first one is this do not reset prefetched buffer when doing multi-chunk. I assume reads is the rest of that statement. We talked about this a little bit this morning. Adam and Igor and I met. Oh, Igor, you're here. Never mind. Igor, you talk about this. You know better than I do.
Well, not to say that it's a much of improvement, but I observed that during these where duplicate reads from RocksDB when I'm generating maps or other stuff, and that's the weird case when RocksDB initially prefetches large chunk of SST file and then proceeds with reads of the same chunk using much lesser block. And it appears that we have some issues with our internal prefetching, which resets these prefetched blocks too early, and this would think like that. So I could see some improvements in statistics or performance counters that we first shared, but not much in real performance numbers, to be honest.
So I'm still convinced that this is really a bug in RocksDB more than it's us, but I guess this probably helps, right? Well, theoretically helps.
Well, it's definitely better than so. It's we the issue is that we still have this buffer in memory, and instead of that, we reset it and to disk. So I believe disk IO has own copy in cache, and that's why the improvement is not that big. But not much sense in previous reset we did. So.
Okay, well, Do you also want to talk about your other PR here about
Well,
oh,
the other one is mostly about enabling the switch from reg deletes to potential deletes on the fly. So originally we need to restart for that. Uh, and since right now I'm experimenting with using range deletes unconditionally, it's better to have to be able to switch this behavior on the fly. Not to mention that some minor improvements possible.
yeah,
Some improvements were introduced as well.
yeah, I was gonna ask if you're doing a lot of experimentation right now, it'd be really interesting to know whether or not the PR I made to enable the ability to do compaction on iteration helps here or not.
You mean your recent tunables?
Yeah, I have no idea whether or not that will apply for delete range, or if it's only going to be useful for when you have individual delete tombstones.
Uh, I don't know yet. Uh, oh, yeah, I haven't looked at this stuff in this aspect from this point of view, but do my best to.
Sure, sure. Just if you happen to be doing other experiments,
Yeah, yeah.
I'd be very interested if that shows any improvement or not. All right. I think you're sort of the only two new PRs I saw this week. Although I apologize to anyone if there was something I missed. Um, let's see. I saw one closed PR, and this is also from you, Igor. You're the person doing all the work this week, I think. Um, So this is you're enabling 4K allocation units for BlueFS. It looks like you're merged that finally.
Right, but honestly, I don't expect much performance improvement from this PR, but rather might sometimes make it worse. That's primarily tended to fight to fight unexpected allocations on highly fragmented disks. So
Yeah,
yeah, so right now we don't care about the amount of continuous chunks at BlueFS drive. So we are able to fall back to 4K allocation unit. Hopefully this wouldn't happen very frequently and wouldn't result in. And yeah, on the other hand, as we talked earlier today, we might want to investigate if fragmented SSTs impact performance. So since this stuff makes fragmentation even more possible, and actually, when RocksDB writes SST files at levels above 0, I believe it performs. So there are no random access. So at that point, it has all the data required to write, and there are no much need to have fragmented uh, SSTs for them. We might want to consider some improvements in this respect. I mean, having SST files, solid SST files rather than making multiple chunks. But right now I'm running some experiments to check what would be the benefit.
Very cool. I think it's a good area to look into. Okay, let's see. Moving on to updated PRs. Another one from you, Ikar. Your user-bounded iterators and ARM range keys. Looks like Corey reviewed that and approved. We just need QA on it now.
Yeah, and that's actually an issue which one can face. And it's in the same scope as many of our issues we have got with RocksDB, which is impacted by tons of tombstones. And yeah, I managed to produce that issue, and in some cases, map clear function, which is issued on object removal, might cause pretty significant write stalls. Again, due to RocksDB enumerating all the almost full database sequentially. And recently we've got another PR from Corey with the same improvement on collection listing, and we had a bunch of similar stuff for different namespaces before. So that's a sort of incremental improvement graded RocksDB.
All right.
And I believe that's the last PR from me.
Yeah, I'm hoping that we're kind of nuking this issue with tombstones from orbit. We've got multiple PRs coming in from multiple people, all trying to solve this, and hopefully we'll just kind of through a combination of lots of different attempts
Yeah, but
fix it.
unfortunately, I have a feeling that we fix specific cases, but generally we might get this or that here or there, that issue again. So,
Yeah,
well, for we still don't have quite reliable reproduction of the issue, neither we got enough knowledge, the root causes, I believe.
there was a really easy way to general effect of tombstones causing slow iteration a couple of years ago by using RGW with the delete range configurable that we have set to allow delete range even with a small number of deletes. That could pretty quickly cause issues.
Well, I tried. Uh, I tried RGW deletes with in my recent experiments. Not sure I switched to range deletes, but I don't know. I don't know. So perhaps it somehow depends on hardware resources, but in my case, this issue is not easily reproducible. So I managed to do that a couple of times, but I can't say that it's pretty easy to do.
Okay. If you're still struggling, let me know and I can try to reproduce the experiment that I did a couple of years ago and see if I can still hit it when we change the settings for the threshold for delete range and just see if it happens again.
Okay.
Uh,
Not to mention that some other settings might impact the behavior as well, like BlueFS buffer IO.
That's true. That's true. And there's a lot that's changed in the last 2 or 3 years. So perhaps I won't be able to hit it as easily as I previously did.
Yeah, and well, one more note, maybe relevant, but no. So, recently I learned that SpeedDB released open source version of the drop-in replacement for RocksDB. We might want to try to use it as an alternative engine at some point. Let's see.
So it's been a
I'll
long
suffer
time.
from.
Yeah, it's been a long time since I've looked at it. I know Adam has already also looked at it, but from what I recall, I didn't think that the improvements they made would help us a lot. Um, Maybe that's incorrect, and they may have also improved it dramatically in the last year or two. But the last time I looked at it, I wasn't convinced it was a huge improvement for us.
Yeah,
Was
and
it?
that's why I believe we need a bunch of test cases which are able to reproduce this RocksDB performance gradation. So, yeah,
Igor, you may know more about what they're doing than I do, but I thought that they were doing a lot of work very similar to like the whiskey improvements for running qualification with
well,
certain.
well, actually, I'm not aware on this stuff in detail. So,
Okay, okay,
but as far as I understand, as you mentioned, you tried that before. It should be quite doable to bring it to our code base, and it's not that hard, right?
I think so. I mean, I believe it's just basically very similar to RocksDB with modifications. Um, but I'm not entirely sure. Adam, I mean, you probably know the most about it of any of us. Do you remember what it looked like, or what the behavior was?
Not really. I just remember I got the SpeedDB to integrate it with Ceph, and I ran the tests that I actually did have at the time, so I could get a comparable results. And the results weren't amazing. Let me try to find a link. There was some improvement, some degradation. Overall, I do not even claim that my tests were the best. It was some 4K random writes, some mixed reads writes. I remember there was no OMAP operation, so maybe on that it will be better. But
Okay,
the baseline is I did not read any document about how would SpeedDB differ from regular RocksDB, and as it was closed source, I was not even so much interested at that time. Now it's changed.
sure, sure. With it being open source, we can certainly do more to try to uh, understand what it's doing differently. I still think, though, that the biggest improvements that we're likely to see immediately are in the Red Hat log behavior, which, Igor, I think maybe your work is more important, frankly, um, and then also the behavior of tombstones with iteration. But we're already kind of trying to fix that anyway. So
Yeah, yeah,
uh,
and uh, so I'm definitely planning come back to this alternative write-ahead log implementation, and I've got one more idea where it might be helpful, which is absorbing write stalls, which RocksDB triggers during compaction from time to time. So if we have large enough external write-ahead log, we might want to avoid the avoid relevant latency raises. Just
Are you
thinking about that, but yeah.
are you actually seeing write stalls during compaction in practice?
Uh, yes, and well, doing my last experiments, I've got a bunch of them with new settings, and still on my backlog to check the original behavior. So I have some feeling that new settings trigger compactions more aggressively, and these might cause more frequent write stalls, but need to double check that. But anyway, I've seen some latency peaks, periodic latency peak in the field multiple times. And again, I have the feeling that it's caused by RocksDB, so we can absorb that with our external write-ahead log. It would be great, I believe.
Yeah, yeah. I was very, very impressed by the numbers that we were seeing by your experimental work earlier I think in the spring. We were looking at that. Um, it's definitely, I think, worth continuing effort on that. Um, I mean, you are with improved RocksDB settings. I think we were seeing like 122,000 write apps for a given OSD, which is really, really good.
Yeah, well, hopefully this stuff.
Yeah. Okay, let's see. Moving on. Next PR, upgrading to the latest RocksDB from Facebook. I'm reviewing that one. The gist of it is that we can't switch over to the RocksDB version directly. We have to use our existing branch that has a fix that was implemented a couple of years ago for upgrade scenarios. The author was trying to push a branch directly to our RocksDB repo and didn't have permission to do so. So I just this morning asked if they could fork that repo directly, branch from our master version, update it to RocksDB's latest, and then it create a pull request from their own branch and their own fork. So we'll see if they have success doing that. Otherwise, maybe we need to look at access permissions, but I don't think that would be necessary. So anyway, that one's still in the works. And I think the last PR I have here is that Laura made an additional, I think, review of this balancing score PR from Josh Solomon that he kind of described for us last week. So just a little movement on that one. We'll see if that finishes full review soon or not. In the no movement category, I made it about not even quite halfway through, but I think I looked at the most recent stuff. So there may have been a couple here that were closed by the bot, but otherwise, I don't think there's a whole lot to talk about there. All right, so that's it for pull requests. Let's see, Josh. We didn't finish your discussion from last week, so would you like to continue talking about your the latency spike issues that you were seeing?
Yeah, and actually, since the last time we met, we've pretty much tracked this down. So I followed the tracker there. I'm not sure if folks have actually looked at it or not, but I'll very briefly say what we were seeing, and then I'll talk a little bit about what we found to be the cause. So we have this Golang monitoring software that we use. We wrote it ourselves. It gives us things like a histogram of latencies, including max latencies over time periods. It's of course a histogram bucketed, so like if we see a 5-second spike, that could be anywhere between 2 and 5 seconds, just due to how our monitoring works and that sort of thing. But we also set a 10-second Rados off timeout in the software. And what we saw after Pacific upgrade was that multiple clusters, all of a sudden we start to see this timeout fire, where it almost never fired before. And it was very regular that we'd see 5-second, 10-second bucketed latency spikes, versus before some of these clusters that were better behaved, it would almost never go over 1 or 2 seconds. So we saw this a lot. The cluster never reported slow ops. The OSDs never reported slow ops, so we couldn't use any of the usual like slow op investigation methods to go and figure out what was happening there. They would just not report it. And once we put all those clues together, Alex M immediately thought, aha, I wonder if this is a messenger level throttle. And so the issue is, due to a decision made years ago by our predecessors, all of the throttling perf stuff had been disabled, so we couldn't actually inspect the throttles. So we did turn them on in one of our clusters. We've now since turned them on everywhere because like there's just no reason to have them off. There was a performance concern years ago, but like I don't think it was ever substantiated. It was like, oh, some vendor told us you should just turn this thing off, and so we did. But there's lots of those sorts of things floating out there in the ether that just are not good ideas. So anyways, we reverted that, and it was very clear that the client message throttle was triggering every single time we saw one of these huge latency spikes. And so, of course, we went and did digging and found out that had been re-enabled in Octopus and Pacific. It would have been re-enabled in Nautilus 14.2.23 had that ever been released, but it was 0 in Nautilus. And the funny thing is we actually had this throttle disabled previously. When we upgraded to Nautilus, we went and looked, we're like, oh, it's set to 0 now, so we don't have to have an explicit disable anymore, so we got rid of it. And so when we upgraded to Pacific, now the throttle got enabled for the first time, essentially, for our block clusters, where it had never been enabled before.
Was that the one I did? Was that my TR?
Yeah, exactly. And the thing is, like, and the thing is, it doesn't, just like in your test, it doesn't show up in benchmarks. Where it shows up is in these uncontrolled public workloads where we have, who knows, some customer that has a high queue depth workload that also hits one of our OSDs. And so when I looked at the implementation, and this is where like I filed a ticket where I asserted I think I know what the problem is, but at the same time, it's great if someone who's actually an expert in this code would actually like confirm or deny my understanding. But what it looks like is in the messenger, the way that throttles are implemented is basically once you run out of a throttle resource, the connection, each connection that tries to get a throttle resource and can't get it just gets put on a 1 millisecond delay timer.
Oh.
Which is a horrible starvation issue. We actually had a case where our monitoring suite was actually starved for 3 minutes straight. Could not get any IO through to an OSD. And that's not surprising because all it takes is one customer who does keep getting through to the OSD over and over and over again. And all these connections that get delayed just keep getting delayed. They can never get their IO through. So basically, it's a very starvation-prone algorithm. So we've just turned the throttle back off again, and things are way better. In fact, our P100s are, on some of our better behaved clusters, P100s are now lower under Pacific than they were under Nautilus once we disabled this throttle.
And that's what I would have expected to see. I was really surprised that you were seeing higher latency because in all of the other tests that we've done, it's done better usually. So
yeah.
Okay.
Yeah, so basically, we tried setting this throttle so the default in Pacific is 256. We tried setting it to 4096. It wasn't high enough. We set it to 16384, and it mostly helped. But like, and so I mean, I understand the reasoning that I eventually finally dug out of some Red Hat documentation somewhere is basically you're trying to prevent a OSD flap when there's too much client traffic. Right? Is that the base reason for this?
I think so. It's been a while since I looked at that, but yeah, there was.
And so like the setting of 256 probably makes sense for a spinner. don't know that it really makes sense on Flash, where like you could get 30,000 IOs done sub-second in some cases, right?
Yeah.
So
Yeah.
when I did some digging around the internet, of course, everyone has their own setting for this. I did see someone set it as high as like 64K or 64 keV.
Okay.
But I mean, I'm sure most people are just like setting it to random stuff. And then once their problems go away, they never really think about the implications are of how they're setting it.
Yeah.
So anyways, like I said, we've turned it off because that's the only thing that we found was safe, and or at least in our block workloads are much happier with it off than on at pretty much any level.
Okay. Is that 1 millisecond delay configurable, or is that hard coded?
It's hard coded. And actually, I have a
Jesus.
PR
Okay.
up because I was actually really scared because when I was tracing through this, the units for that timer value are actually wrong in the header. This goes back to like, I don't know, 2016 or something like that. The units were actually changed on this timer to go from milliseconds to microseconds. And so it actually looks like it's a 1 second delay until you dig into the implementation. You find out it's actually microseconds underneath the cover. They updated the units in the CC file, but not in the header. So I do have a PR up for that somewhere to like fix the header file so the units are documented correctly. No,
Okay.
it's not configured. I'm not, like at the end of the day, like the only way to really avoid starvation here is you almost want to have like the state machine throttle mode where as soon as you're throttling, every single connection has to go in a queue, and you're always
Yeah.
servicing from head of queue, and then you get a FIFO across connections, and then you avoid the starvation problem. Even
Yeah.
better would be to actually have the messages in a queue, because then you get first come first serve on the connections, but that destroys the whole point of the throttle, which is don't pull the messages off the connections until we're ready to, right? So the next best thing is all the connections go in a queue, you FIFO the connections. Every time you service a message off the connection, you put it at the back and you keep doing it.
Yep.
So, but this would have to be done for every throttle implementation to make them all fair, right? Like this is not just like, oh, it's just this one throttle that has this problem. Basically anything in the messenger has this problem. And I haven't looked at things like the other throttles, see how they're implemented, but at least in the connection, inbound messages in the connection, they're all susceptible to this problem.
Fun.
Yeah.
All right. Well,
So,
hey.
anyway,
but how does this explain the right amplification you observed?
It does not. Two separate problems. We still don't know what's causing the right amplification. So, like, if we've got time to talk about that one, we can talk about the digging we've done the last week on that one too. But
absolutely.
Yeah. Yeah. So, anyways, on the P100 thing, I'm like glad we figured it out. Glad we were able to tweak it with the setting to make the problem go away. I did file that tracker. It's one of those things where it's like I would love to just go and work on it myself one day. I have no idea when I'll have time though. So,
yeah. I've been kind of feeling like we've been ignoring the messenger too much. There's a lot of stuff there that I'm kind of scared of, and this maybe reiterates that we need to go through and look at it a little bit more closely again. Oh boy. Okay. Well, yes. Continue on.
Okay, so right amplification. So we were all excited last week because I think you and others were trying to think, what if it's the deferred rights thing? So we spent a lot of time trying to chase that angle internally. I think we've pretty much concluded from the available stats from PerfDump that there is no increase in the number of deferred rights between Nautilus and Pacific on our systems. It looks pretty much equivalent. I did want to correct one thing I said last week, which is I thought all of our OSCs were 4K MAS. That's not true. Anything that was deployed under Luminous and before are actually 16K MAS.
Yep.
And so, as you would expect, those OSDs show higher deferred write rates than the 4K MAS ones in general, and we can see that. But there's no change to either the 16K or 4K in terms of how many deferred writes are happening per second once we do the upgrade. So it's not a change in the count of deferred writes. Could it be the deferred writes are more expensive? I mean, that would probably take some digging If that's
Okay.
exactly what's happening there, I don't know. The one thing I did notice is when I filed the ticket, it looks like this is where you start to get into like these, you can go and slice the statistics to give you all sorts of interesting numbers, but whether they're actually like relevant, you have no idea. But it looked like the average IO size to the disk increases when we go to Pacific, but it looks like it increases more for the 4K MAS OSDs than for the 16K MAS OSDs.
Okay. Interesting. More absolute or more as a ratio of the IO size? Or both?
Let me bring up the ticket. Okay, so I'm just looking at the graph. The tracker is here, 580, 530. Put in chat for easy reference. So I'm looking at the third graph of the ones I posted. So like it looks like the 4K MAS hosts, the average IO size jumped from, I don't know, you want to call it like 13 KB up to, or this is probably kilo, up to like 16.
Mm-hmm.
Versus the 16K MAS ones jumped from, call it 17 and a half up to, I don't know, not too much higher, 18, 19 or something like that.
Okay.
And then you can, like, you can also see there's that yellow line that kind of transits between the top group and the bottom group.
Yeah.
That host we were actually reconditioning rebuilding all the OSDs on. Sorry, we've rebuilt half the OSDs on it, essentially. You can see the average IO size is dropping, as you would expect, because the MAS is basically dropping on average across the host.
Sure. Out of curiosity, before that transition period started, it almost looks like in the 4K case, you've got some kind of like binomial distribution. Right? Like it's
Yeah,
like some of the
it is weird. I don't know why.
Okay.
I'd have to go and dig. We've had like these systems often have a mix of at least 2 different generations of hardware in them. And then also deployment across, in this case, it would have been deployment across Luminous, Nautilus, and then obviously now Pacific's on the system. So like they have all these interesting histories where we almost have to dig on a per host group basis to go and figure out, okay, what is the exact history of how we got here? So I don't know how interesting that binomial distribution actually is at the end of the day, but you're right. I did notice that. I thought it was weird, and it does seem to disappear across the upgrade from Nautilus to Pacific.
Yeah. I was curious if that would help explain any of this. Like if we could understand the difference between those. But I don't know if it does or not. Maybe. Okay, but the big difference, right, is that we see that the ones with a 16K min-alloc size are definitely showing higher write sizes than the small one, as you would expect. Although it is interesting that, and they're not that far apart.
Yeah, they're not terribly. You're right. They're not very terribly far apart.
And in the 16K case, it really looks like there's really no difference. Like, it doesn't appear that there's any growth, right?
It's very small. Yeah, like I mean, to my eyes, there is a small jump, but the other weird thing is you can see that the average IO size was actually falling in the recent history of Nautilus up until the upgrade, and then it looked like it started increasing after that. And like the unfortunate thing is that that cutoff there is as much history as we have. So
yeah,
we have monthly cycles, we have weekly cycles. There's all sorts of interesting cycles that happen in our system. So it's entirely possible if we actually had like 6 months of data, you would actually see some sort of monthly cycle here or something. So
yeah.
what I did attach to the ticket is we did get a perf dump across 3 different OSDs on a different system that we upgraded, both before and after the upgrade, the same 3. So I was hoping that some difference would jump out if we looked at the before and after. When we looked at it, we couldn't find any difference of note, but
Very interesting. It's also kind of interesting that, I mean, it almost looks like at the very beginning of this trace, at least some of these hosts look like they were in the same ballpark as after the Pacific upgrade, right? Like the ones that had the 4K min-alloc size, it looks like half of them maybe started out pretty close to where Pacific ended up.
yeah.
I mean, not quite. They were definitely a little lower there, but like you said, there could be some fluctuations over time. But then you've got these other ones that were definitely dramatically lower. Is there any way to tell to find out any information about these different groups of OSDs, the ones that were in each
I'm
yeah.
quickly bringing that up now. The binomial distribution actually still exists. I'm sorry, I'm just trying to, it takes a while for the whole graph to compute. I'm just looking at like the last hour.
Okay.
Actually, yeah, it looks like, so it looks like it actually, the binomial distribution started to show up again in the last few days. There's not, yeah. So look, I'm actually just looking at those 2 groups of hosts. There's nothing that stands out to me why they would be different. Actually, they're the same generation of hardware. They would have all their OSDs would have been deployed on Nautilus.
Are there any correlating variables like by cluster or by workload or anything else that would explain it?
The only thing is the ones that in the binomial distribution, the ones that showed the higher write IO size were the most recent 12 hosts to be deployed in the cluster. So perhaps it just means that they're the least aged OSDs, if we want to put it that way.
Sure. So larger IO sizes at the disk level, potentially due to lack of fragmentation?
Right, yes. Yeah.
Yeah.
That could totally be.
Okay.
Yeah.
Okay.
Josh, that write IO sizes you showed, it's both read and write IOs, correct?
Sorry, that's only writes.
Okay.
I'm going to quickly compute a graph of read.
Somehow, Adam, we've come back to the fragmentation topic again today.
We would, but last week Josh said that also total amount of data transferred is increased, and that cannot be explained by fragmentation.
if we were dealing with very small IOs, could we end up with more writes if we were fragmenting over small units? Could we end up with a lot of hanging bits of data?
With more fragmentation, I can expect that we need more metadata, but increase would be a very minuscule. The other factor would be if we would switch more often to deferred writes with more fragmentation, but I don't think we work that way.
Well, and Josh said he didn't see more deferred writes anyway. I was wondering more about like is there any possibility that we end up with additional writes due to needing to fill in small gaps, I guess, but maybe that doesn't make any sense.
I know that when BlueFS log is highly fragmented, its updates can become significantly larger.
Okay. But that should be a small amount relative to the overall amount of data being written, right?
I lost you for a second.
That should be a small effect relative to the overall amount of data being written, right?
No, not necessarily, because if your BlueFS log is fragmented over a multitude of small allocation units, then after each update to BlueFS log, when you need to no, but you don't fix the size. Sorry, we don't fix the BlueFS log size on an extension. So yeah, that wouldn't be very large. Sorry.
I was thinking more just the fact this is RBD, right, Josh?
That's RBD.
I mean, BlueFS, the amount of BlueFS data should be very, very small relative to the amount of BlueStore data. Am I thinking about it correctly?
Unless you get rights.
Yeah, exactly. But we didn't. But it sounds like we didn't see an increase in deferred rights. But maybe if they were more fragmented, I suppose. If there were a lot of deferred rights, but we saw more fragmentation in BlueFS. Josh, was there a high amount of deferred rights in both cases? Like, I know you didn't see an increase, but was it a high amount?
What would you consider a high amount?
I don't know. Let's say just to start with, like we're half of them deferred rights.
Let me.
Well, as far as I remember, it was pretty high, and yeah, indeed, I didn't see the increase after upgrade.
Yeah, in our 4K OSDs, we're doing. I'm just looking at a different cluster. We're doing like one to two deferred write-offs per second. So not very many. And then the 16K ones, we're doing about 200.
Okay, so a lot more deferred rights on the 16K cluster.
Mm-hmm.
But those are the ones that you didn't see if you saw any rate amplification, it was pretty small.
I'm just looking. Yeah, so like that's so on this particular cluster I'm looking at, the 16K OSDs, that actually looks like it's pretty much all the IOs they're doing are deferred.
Yeah.
Oh, sorry, no, I'm calculating this dumb. Half. It's like half.
Okay. So a lot of IOs that are sub 16K.
Yeah.
But not all of them. Okay, so you're seeing a bigger effect with a small min-alloc size, seeing a minor effect with a 16K min-alloc size. I mean, I guess that makes me kind of suspect metadata more, like you were saying, Adam.
I did quickly compute reads. There's no increase in reads from Nautilus to Pacific, or if there is, it's not easy to measure. Yeah, I don't really see anything interesting there. Average read size is something like 22K in this one particular cluster. Except for, it's actually really funny. So the less fragmented 4K OSDs and the 16K OSDs have a average read size of closer to 32K.
Okay.
Which makes sense. That must imply there's some sort of like pretty heavy 32K workload, pretty dominant 32K workload or something like that going on here.
Sure. Do you have OSD logs from before and after the upgrade?
We collected those. Is Alex? Yeah, we actually did another upgrade recently. We actually collected with some debug levels cranked. I don't remember which ones. Alex, which ones did we crank for that?
Debug Blue Star 20 for like 5 seconds.
Okay, I don't even need that. I was just wondering if you had the RocksDB events in the OSD logs. Did you guys look at the?
Yeah, I didn't look in detail, but we can provide those. That's a good idea.
If you want to, you can try running. There's a script in CVT for just making those statistics look nicer. I've mentioned it before, but you can try running this Python script on the before and the after ones, and that will give you a whole bunch of information, like summary statistics on like the number of input and output records and the write rates for RocksDB. That might actually tell you whether or not RocksDB is like writing out more data before and after. Maybe it will help explain it if it is.
Good idea.
I imagine you'll see really different behavior on your 4K and 16K min-alloc size OSDs as well.
Yep.
Well, that's super interesting, Josh, and especially thank you for digging in on that issue with the messenger. We kind of tested that and we're like, okay, it's looking good. Let's merge it, and didn't hear any issues from anyone, and that's unfortunate.
Yeah, and like I have we have not attributed any user complaints to it, although we know that users were seeing it. Like I've gone and run FIO and VM over multiple days, and like I saw FIOC, like 10 to 20 second latency sometimes. So I know it was hitting people, but nobody complained about it, and we wouldn't have noticed either, other than the fact that we had started paying a lot more attention to our P100s starting about a year ago. So
Yeah.
I wouldn't be surprised if this is like, especially like if people have been running Luminous, they would have been seeing the same thing. I'm assuming. Like I didn't look at the V1 messenger. I'm assuming its throttle implementation is the same, but maybe it's not.
Yeah.
But it's like it's really easy to miss because even your P99s look fine, right? Like our P99s were fine
Yep. Okay.
because
Okay.
most of the IOs get through, right?
Yep. Yep. Exactly. Exactly.
So, yeah. Okay. All right. Well, we'll try to dig at our those RocksDB logs a little bit and see. But I definitely admit on our side we're kind of like out of ideas at this point as to what to investigate, other than like going down the path of like really heavy tracing of IO and trying to pick that apart, which we don't have time to do.
Yeah. Yeah. Maybe try seeing if the RocksDB statistics look any different for before and after. That should be a quick thing to try. Yeah.
Just run briefly through performance counters for ticket SD683 specifically. What I can see is a pretty high difference in log bytes at BlueFS. This might be a random fluke caused by compaction.
Right.
But maybe it's wrong. So would be interesting to see the difference for other OSDs.
What's the exact stat name there?
Sorry?
What's the exact stat name that you're looking at?
So it's BlueFS section log underscore bytes in Nautilus. Maybe wrong. It's log bytes. That's amount of. Yeah, so it's log size, but not the amount of writes. So Pacific has got two variables, log bytes and logged bytes. Log bytes, if I remember correctly, that's log size, and logged bytes, it's amount of bytes written to log for the period. And unfortunately, it lacks the same stuff. No. In Nautilus, logged bytes is present as well, and it's 0 for 683. Why it's it's 5 megabyte for not 5, 53 megabyte for Pacific. And the amount of compactions is 3 versus 0. So I'm curious if there is the same delta, well, similar delta for log underscore compactions and logged bytes. Again, in Nautilus, it's both 0, they are both equal to 0, and for Pacific at 683 SD, they are pretty significant.
So one of the things that we do have in Prometheus is BlueFS bytes written lol. And that does seem to increase from, for example, 1.5, 1.3 megabytes per second to almost 2 megabytes per second.
1.3 to Well, I need
So it
to
looks
check
like
other. I'm. Uh, so the increase in writing to val might be caused by multiple factors, actually. So increase of metadata, increase of amount of deferred writes. Yeah. But again, well, looking at 683, I can see 9 megabyte on Nautilus versus 13 megabyte in Pacific. So not that large difference, I'd say. But what's really differs is logged bytes. And I'm curious if this delta is persistent for our nodes, our
right.
deep demons. And the second question would be if it's persistent over time. I mean, the compactions are happening permanently, or this goes away after a while.
Right. Yeah, we should be able to see that through the RocksDB log parsing as well, right? Off the logs.
Please do not confuse log compactions with DB compactions.
Okay.
It's a different stuff, and I don't remember if log compactions are reflected in the noisy logs. But at least again, for these two dumps, this is the most suspicious thing.
Okay.
Because, well, some increase in bytes written val, well, it's like 30-25%, not hundreds of percent as you show in your pictures. So yeah, these logged bytes looks the most suspicious so far, but the question if it's observed in other dumps and all the time.
There is also one change. Now BlueFS reports a much more space available for storage, and it's consistent with the change we made, that previously we had it separated, storage for BlueFS and for block data, and we had a mechanism that regularly gifted or reclaimed some large portions of the main device for BlueFS, so BlueFS can get a underlying continuous space. Then we changed it because it wasn't a very good solution. So BlueFS is using basically the same allocator as main devices. That is possible that it might make it more prone to fragment the data, fragment BlueFS files, including BlueFS log. It's not that I'm basically telling that it is fragmented, but definitely now BlueFS files are more prone to fragmentation than before.
And BlueFS log might grow faster and hence causing function more frequently.
Well, guys, we are a little bit over. Is that a good place to wrap up, do you think?
Give me a second. I'm checking SD 300. Curious
Yeah.
if there is the same delta for log bytes there. Yes, and it's there. So yeah, Nautilus has got 0 log bytes and 0 log compactions, while Pacific has 4.5 megabyte logged bytes. So yeah, I'm curious. I'd suggest to check logged bytes at larger scale, how it behaves.
Okay. We export a bunch of these perf dump things to Prometheus. I don't think we export those ones yet. So we can do that and then observe across one of our upgrades, for example, and see what happens long term.
That sounds hopeful. Huh.
All right. Yeah, I also have to run to a meeting. Thanks so much for your time.
All right. Yeah, thank you. Thank you.
See what more we can find.
Yeah. Thanks for all the work you guys have been doing. This is really, really good data that we're getting, so we really appreciate it.
Awesome. Okay. Have a good day.
All right. Yep. See you later.
Yeah.
And guys, I think it's probably good point for us to wrap up too.
Thank you, guys.
All right. Have a good day, everyone.
Thanks, bye.
See you next week. Bye.